All right, this is a continuation of our tutorial on how to map flood risk under different sea level rise scenarios. So this is part 2. We've previously acquired the data we need and assembled it in Arc Pro. So now the next step is to start processing that data. So we have two kinds of data here. Essentially, we have the municipal boundaries for the state. We're kind of focusing very closely here in Boston. We're going to hold that for a second. I'm going to turn that off. Our main concern is going to be these raster tiles that we downloaded, which are high-resolution digital elevation models to model where the water will go. They look like clouds right now, but essentially what they are is just single-band rasters where every cell indicates the height. So the values, the lighter the color, it just means higher elevation, and darker color means lower elevation. So you can see all the water out here. So what we want to do is we want to mosaic these images into one solid image rather than being one at a time, because right now you can see you could turn one off and turn it back on again. And in order to process it, we need to be one thing. So to do that, we're going to use a tool to mosaic these. Before we do that, it's a good idea to check what you're dealing with. So I'm going to right-click on one of the rasters and go to the properties just to inspect it. One of the important things to understand about it is how the raster is organized. So these are TIFF images. So it's a typical type of raster image. The raster itself, as you can see, tells you a little bit about itself. So the cell size says a 0.5, which means it's a half-meter resolution, which is very high resolution for topographic data. It's a 32-bit floating point raster, and it's got one band. So I'm just scanning it right now. We're going to use this when we tell the computer how to organize this. So, okay, I know what I'm dealing with. So I'm going to mosaic these. So the way I do that is I'll use a tool from the toolkit. So under the analysis menu up top, I click on tools and I can find tools that I'm going to use. So in this case, I happen to know the tool that I need. And if you know the name of it, you can just type it in. Alternatively, you can always go to the toolboxes and go through these various categories of tools, which works fine too. Sometimes it's good to know where they're at, but I know what we're doing here, so we're going to save a little time. So the tool we're using is called Mosaic to New Raster. And so that when I type Mosaic, it pops up, and I'll choose that tool. And so it's going to ask for the input rasters. So I'm going to throw all of the rasters I've downloaded here into it. So I'm going to hit this little down button, which lets me kind of select all of them all at once. So I'm going to tick off. I was going to say check off or tick off at each of them. So they're all selected. Okay, they're all selected. Hit add, and there they are. They're all there, and they're gonna output into one one object. You need to tell it where you want it to go. So I'm going to put it into that default geodatabase that's in our project folder. So in this case, it's that flooding GDB item that you saw that was created when we started the project. So I'm going to double click on that to open it. So it's blank. There's nothing in it right now. But what I want is for it to have the name of the geodatabase there. So when I hit OK, it accepts that as the location, because a geodatabase is essentially like a folder where stuff goes. And then we need to put the name of it. So in this case, this will be the DEM. So I'll just call it DEM. That's what we're dealing with. The spatial information we'll just take from the current map. That's going to tell it what projection to use. Pixel type, when we looked at the raster information, we saw that it was a 32-bit float. That was the type it is. It has, oops, we don't want to deal with that. We'll leave that alone. Number of bands, that is not, it's one band, meaning it's kind of like, there's just one kind of data there. You can leave the operator alone, doesn't matter what that is. So that's all we need. So I'll run that. It might take a second depending on the speed of your computer. All right, so hopefully that works okay. When you do that, you'll notice now you've got, nothing looks changed, except you'll notice it's more seamless to it. So I can turn off all the other ones, since those are now incorporated into this one mosaicked raster. I tend to turn things off that I'm not using so I don't get confused about what is currently active or visible. Okay. All right, so we've got this one raster. You might see some banding there. What I've noticed is that that banding sometimes is a function of just the screen. It's like memory issue, but it's actually whole. So don't panic if you see like a strip of something like that. It actually did work. It just it's not behaving. All right, we'll fix that in a second. The next thing we want to do is we want to clip it. So right now it's like a big square, right? It's a rectangle, but we want to clip it to follow the Boston, the shape of the coastline in particular. So what we're going to do is we're going to use the municipal boundary to do that. So I'm going to isolate Boston and then create a separate layer out of that, and then I'm going to use that to clip the rasters. So under the map menu up top, one of the options is to select by attribute. So we're going to select a polygon based upon its name. So so we're selecting by the municipal boundaries one. So make sure you're looking at the right layer, and then we're going to choose the town is equal to, and we're looking for Boston here. All right. So we'll hit OK. Okay, you can kind of see it's outlined already. And then what we'll do is we will right-click on that layer, and we're going to go to Data, Export the Features. We're going to basically create a separate layer of just Boston. And so we're going to, it's giving me the input, that's what I'm putting in, the output feature class. We're going to put this into our geodatabase, so make sure you go into your folders again, looking for that familiar flooding folder. And specifically, we want to go into the geodatabase again. So we're putting the output into our geodatabase. So we'll give it a name, we'll call it Boston. Okay. And then we'll hit OK. And then now we have an isolated layer for just Boston. In fact, if you zoom out a bit, you can see this blue thing is just Boston. Okay, that's what we need. So what we'll do with that then is we're going to basically use this to clip the raster, so it'll throw away all the stuff that doesn't fall inside of Boston, and that will make the map look nicer, and also will restrict our attention to just the data we need, which makes processing a little faster too. We're gonna use another tool from the analysis toolboxes. So we go into the analysis, we'll click on tools again, and this time the tool that we're looking for is called extract by mask. So in this case, the mask is Boston. So we'll choose the extract by mask, and the input raster is the DEM, the mosaic layer that we created. The input raster feature mask data is going to be Boston. It's going to create a new output, right? So we'll say, call it DEM Boston. When you're just a point of clarification, when you're naming the rasters, keep the names really short and simple, because it doesn't like long names, and it will scream at you if you try to put spaces in the name. So definitely avoid that with rasters here. Okay, that's all it needed. So it's got the name of the output raster that's going to be created from the mask. We'll run that. All right, so now we have, so let me turn off Boston, and I'll turn off the original DEM. And so we have a new DM, so it's just been, you can see it's been clipped off. It fits, it's just a raster that fits within, so it follows the contours of the city. So it's exactly what we want. So now that we've accomplished that, we have our data spatially ready to roll for doing our analysis. And so the next step is going to be to decide how to identify the depths of interest. So the strategy, just overall, so we're clear, is this raster right now, what it's showing us is the variation in elevation across the area. In fact, it's might be a little easier to visualize it if you use a slightly different symbology. So if you right-click on the DM Boston and you go to symbology, one of the default options for the color scheme is what's called a terrain or something they call it topography. It kind of goes from blue to white, so it's kind of this one right here. And so it kind of gives like this classic symbology so that you can see that the white is the highest elevation, and then brown is lower, and green, and then you get down to blue, which is the lowest elevation. So it's kind of trying to mimic what you might imagine on an old-fashioned map, but it just gives you a sense of the elevation. But you look at the values too, what we see is that this gives you the range of elevations that are in the raster. So right now, they run from -8 to 44. And as we saw earlier, or maybe we didn't pay attention to it, but if we look at the properties for this, we can see that under the raster information, one of the things that it's going to tell us in this, rather spatial reference, excuse me, is what units we're dealing with. So this is in meters. So the whole thing is in meters. So that means that includes the elevation too. So the elevation values that these represent are in meters above a height. And so as it turns out too, oh, that's one thing I forgot also. This is going to be relevant. When we look at the spatial reference, the other thing that's really key is the vertical datum. Okay, so you'll see the vertical coordinate system, NAVD88 height meters. So really explicit about what we're dealing with. That really, really matters because, as you might recall from our Excel work, we're working with feet. And that's how the National Weather Service also describes the water heights for the different flood stages. So we're going to be needing to convert in order to accommodate both the fact that we're dealing with meters rather than feet, and secondly, that the datum that's being used here is not the same datum that was used for the National Weather Service numbers, which we'll cover in the next section.